Good morning. Today, I'm going to talk to you about distributed and cloud-based scanning. So, the importance of scanning in cloud environments. Typically, anybody who's an administrator for the cloud would want to do this to identify any misconfigurations or if there's any changes that need to be made. Sometimes alerts will populate from these scans, and that in turn helps the administrator fix any issues. We're also going to talk about the distributed cloud scanning, which is a way for basically anybody to scan multiple hosts utilizing cloud resources. And then we'll also talk about security and ethical considerations. So, an overview of cloud security scanners. Basically, they're just tools to identify vulnerabilities in cloud environments. They're often deployed in cloud workload protection platforms, which can be tailored towards the cloud, whichever cloud, whether it be public, private, hybrid. And when we talk about the main functions of cloud security scanners, mainly we're thinking of vulnerability scanning, obviously, and then fuzzing can be a way for the scanners to test the applications. Security posture assessments, which are automated solutions. These verify if cloud environments and the resources that they host are properly configured. They work on infrastructure as a service, platform as a service, software as a service, and they're used to identify unused assets, map how security teams work, verify the integrity of recently deployed systems, and identify what technologies are most used. So these are extremely useful. And they also do compliance validation, which check adherence to regulatory requirements and best practices. This is going to be something along the lines of governance and compliance, GRC analysts, things like that. And typically, these cloud scanners are proprietary, and they work with their own platform. So AWS Security Hub is a scanner that reports issues and findings within an AWS environment. Azure Security Scanner includes vulnerability scanners and defenses for containers. Azure uses blobs, I believe is what they're called, as a container, which can be accessed through a URL. So, I'm sure the scanner just scans the URL and looks for any vulnerabilities and makes sure that everything is sanitized correctly. Google Security Command Center is Google's proprietary scanner that monitors threats and scans applications for vulnerabilities. So for distributed cloud scanning, basically you would want to use Nmap or MassScan. You could use proprietary tools, as I previously mentioned, to conduct the scanning. However, with this way, you can pretty much conduct your distributed cloud scanning without being agnostic to the specific type of cloud environment that you're working in. Nmap and MassScan, you can use it in pretty much any environment. So learning how to do this with either one of those tools is probably going to be better for you. Just ensure that you choose a cloud provider that is scalable, right? So AWS or Google is probably a safe bet. And then to set it up, you want to make sure that you set up the VMs or the instances in the region that you were conducting the scan in. The whole point of distributed scanning is that you're going to have scanning done in one area or one region, and then another region as well. So you're going to have it in multiple places, and that's what makes it distributed. And then set up for either Nmap or MassScan in the cloud environment. You can install Nmap or MassScan in your instance to conduct the scans in the specific region. So I created a 6-step guide for distributed scanning. It's very generic, and um, basically I just created this just to make it easier to understand how to actually conduct distributed scanning in the cloud. So with step 1, you just select in the cloud environment. Uh, like as I mentioned before, ensure to choose one that has a scalability. And with step 2, you're going to set up the environment. So I made sure to include the fact that you want to choose instances from a variety of regions, because you want that diversity to take place when you're scanning. If you have your instances all in the same region, then it kind of defeats the purpose of distributed scanning. And you would want to also ensure that your regions are chosen depending on your target subnet range. So if your target subnet ranges are all on the East Coast, then maybe you can deploy, distributed scanning within the East Coast, break down the region further, and make sure that you have servers running Nmap or Masscan, north and south of the East Coast. However you want to do it that way, or if it's like your region is the whole United States, or if it's all of Australia or all of Europe, then you would want to make sure that you have your server set up in different areas, in different regions within the country or whatever part of the world that you're conducting your scans in. So for step 3, we're talking about strategy. As I mentioned earlier, divide and conquer. So each instance is going to be given a smaller range of the network to scan. There are tools that allow you to do this, such as Ansible, but you can also manually go into these instances and run the scans at the same time. That's the whole point, though, is to run them at the same time concurrently and in diverse regions. So step 4, leverage the cloud. So you have to make sure that auto scaling is utilized. That's the whole point of using the cloud, is that you can spin up resources and spin down resources as needed. Different scans take on different workloads, and so ensuring that ability is there is going to be extremely beneficial. And then you can also deploy some cloud load balancers, which can also be used to distribute incoming scan traffic evenly across all available VMs. You can optimize your scanning tools. So with this, I just put a couple examples for Nmap. You can use the TAC-T4 option to sometimes get faster results, and with Masscan, you'd want to use the TAC-TAC rate option. And then for data management, so with this, you want to ensure that all of your scans are going to be consolidated in a place that you can access them easier. For my example, I put AWS S3 bucket. It's just a very common way to view data when you're collecting information in AWS. Typically people forward logs, our administrators would forward logs to an S3 bucket, which is consolidated and sent to a SIEM. But in this case, we can use it for collecting scans. And then after the scanning is completed, you want to ensure that the VMs are not being used anymore and are shut down and deallocated. Last thing you want is to be hit with a huge bill at the end of this because you left a VM on. And lastly, I wanted to talk to you about the security concerns and ethical considerations. So when we're conducting these scans, you really want to make sure that you adhere to like compliance and data protection regulations, laws, and typically this is hashed out before the pen test or before the red teaming engagement. And you can do this by ensuring that there's encryption either at rest or in transit, And you can do also strict access controls, so only certain people, maybe one or two people, can be authorized to conduct these scans. Realistically, you only need one person to be able to conduct these scans, so someone who has a lot of experience would probably be the one, someone who's qualified to do it, probably be the one to actually conduct the scans, especially because, you might be able to access sensitive data that would violate regulation laws. So I put a couple on here, GDPR and HIPAA. GDPR is a European uh, general data protection regulation that, if violated, can cost hundreds of thousands or even millions of dollars. And that's if you accidentally access those types of data. So adhering to these policies and regulations is extremely important. And when you're in the cloud and you're conducting these scans, you just never know, when you're going to accidentally scan something you shouldn't have scanned, and then you're going to have to figure out how you handle that kind of situation. So avoiding this by making sure that you're staying in scope, and making sure that you talk to the customer, make sure you get the right IP addresses. All that is extremely important. If you find something that may be outside of scope but might be in scope, that's just something you got to talk to the customer about. Make sure, because you don't want to mess this up.